You ever stop and wonder what's really going on behind the screen of your computer or your phone? It kind of feels like magic, right? You tap an icon and this whole world just springs to life. Well, it's not magic, but it is an incredible story about translation. So let's pull back the curtain and see how it all actually works.
So here's the big question we're going to tackle. How on earth can a machine that's, let's be honest, pretty simple at its core, only understanding on or off, a 1 or a 0, how can that machine run something as complex as your favorite video game? It seems completely impossible, but it's not.
The whole answer starts right here. You have to remember that at its heart, every computer is basically just a lightning-fast calculator, and it only speaks one language: binary. It doesn't understand words like open this file or play this song. All it sees is a nonstop flood of ones and zeros. So how do we bridge that massive gap between what we want and what it understands?
Well, the answer, the absolute hero of this story is software. This is the amazing invention that acts as a digital bridge, the great translator between our human thoughts and the computer's rigid binary logic.
So what even is software? When you boil it all down, it's really just a collection of programs. And a program, well, that's just a set of instructions all designed to get a particular job done.
A really great way to think about it is like a recipe for the computer. A very, very detailed recipe that tells the hardware, the physical metal and plastic parts, every single tiny step it needs to take to make something happen. But to really get it, we need to know that the entire world of software is pretty neatly split into two big categories, and each one has a totally different job. And those two types are system software and application software. You can think of them as two sides of the same coin. You absolutely need both for your computer to work, but they are responsible for very different things.
Okay, first up, we've got system software. Think of this stuff as the foundation of a house, or maybe the plumbing and wiring. It's the general-purpose software that's always running in the background, just managing the computer itself. You don't really interact with it directly, but without it, nothing would work at all.
The most famous piece of system software is, of course, your operating system. Windows, macOS, Linux. But this category also includes some really important background players, like the translators we're about to meet and other packages that just keep the whole show on the road.
Then you have application software. Now, if system software is the foundation of the house, applications are the furniture and the appliances inside. This is the software you actually use to do specific things: write an email, edit a photo, play a game.
And you already know tons of these. Microsoft Office is a classic application for making documents. Oracle is an application used for managing massive databases. Tally is an app built specifically for accounting. See? Each one has a very particular purpose for the user.
So here's the bottom line, the key difference. System software is general purpose. Its job is to manage the computer. Application software is specific. Its job is to perform tasks for you, the person using the computer. One runs the machine, the other serves the human.
Okay, so we have these two layers of software. Problem solved, right? We just write our instructions, the computer gets it, and we're good to go. Well, not quite. There's still one more pretty major communication problem we have to solve.
And this quote from our source material just hits the nail on the head. Even if a programmer is fluent in a programming language like Python or C++, the computer still has no idea what they're saying. It's like you're speaking perfect English to someone who only understands binary. The message is completely lost.
This is that breakdown point. The programmer can write the most beautiful, elegant code in the world, but there's a disconnect, a big wall right in the middle of the conversation. The instructions just aren't getting through to the machine. So, how do we break down that wall? How do we solve this final, crucial communication gap? We need an interpreter. And in the world of computing, this quiet, unsung hero is called the translator.
A translator is a special type of system software, and it has one incredibly important job: to take the human-readable programming language from the programmer and convert it into the only thing the computer hardware actually gets: pure, simple binary, ones and zeros.
And this is the aha moment. Here it is, the full picture. The programmer writes the code, the translator steps into the middle and converts it, and only then can the computer understand the instructions and run the software. That little translator in the middle makes everything we do possible. Now, this translation process can happen in a few different ways. The main tools for the job are called compilers, interpreters, and assemblers.
We're just going to focus on the two big ones you'll hear about the most, compilers and interpreters.
So they both do the same job, but they work in totally different ways. A compiler is like a book translator. It takes the entire program, reads the whole thing from start to finish, and translates it all at once into a new binary file. An interpreter is more like a live interpreter at a conference. It translates the program one line at a time, step by step, as it's running. Generally, compilers make for faster programs, but interpreters are awesome for developers who want to test their code on the fly.
So, let's put it all together and trace that entire journey. Step 1. You tap on an app. That's the application software. Step 2. That app runs on top of the system software, like your OS. Step 3. Somewhere in there, a translator has converted that app's code into binary. And finally, Step 4. The physical computer hardware executes those binary commands.
And that's what's so incredible. Every single thing you do on a computer, from typing a single letter to playing a huge online game, it's all part of this constant, ridiculously fast conversation, managed and translated by these invisible layers of software.
In the end, it really all comes back to this simple but really powerful idea from our notes. As complicated as it all seems, at its heart, software is just a collection of instructions cleverly organized and translated to make our digital world a reality.
So the next time you launch your favorite app, just take a second to think about that incredible journey of translation that's happening in less than a blink of an eye. It really makes you wonder, doesn't it? What other invisible processes are hiding just under the surface of the technology we use every single day?